So first, two disclaimers. The first one is we're not going to get literally to zero copy. This is kind of like one of Zeno's paradoxes. You know, the one where the sailor and the beautiful woman, and Zeno says the sailor can only cross half the distance of the room every unit of time. And the philosopher says that the sailor will never get to the woman. But the engineer says he'll get close enough. And this whole zero copy thing is you're probably never going to get to zero. You might get to the last copy, but you won't quite get to zero. But any progress, if you can cut this in half, and then half again, and then half again, and again, and again, you make an amazing amount of progress. And that's what we're going to talk about today. And the second disclaimer is, I didn't coin this term. I like it a lot. I like it a lot. This was coined by this Data Collaboration Alliance out of Canada. And if you pop the hood on this, you peel back a few layers, you find out that actually this company called Cinci came up with this term. But I find it so evocative because, you know, if you're as Peter was suggesting, if you're in the data world, you wake up every morning and start copying data. That's all you do all day long. Copy, 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 you know? And so to get your head around this idea of stop doing that is kind of a interesting thought. And one of the case studies I've got at the end of this, we're going to talk about, you know, a client who is right there, ready to not copy something, and their initial reaction is, "Oh, give me a copy of that," and you know, just how to talk them in off the ledge of that. So anyhow, that's where we're going. Whoops. Here's an artist's rendition of somebody doing systems integration, I guess. You know, he's got boxes and arrows and stuff. When you think about it, every box is a system, and every line is data being copied. It's just copy, copy, copy. That's all. In fact, we did a project for a medium-sized enterprise, the Washington State Department of Transportation. And when we first got there, they had an 8.5 by 11 sheet of paper that they called with the, 15 boxes on it with arrows between them. And they said, "This is our spaghetti diagram." And we said, that's not your spaghetti. Are you kidding me? That's not even close. So we got their portfolio and started drawing pictures and interviewing people until we finally got to this. This was their spaghetti diagram. They, a mid-sized firm, they have maybe 500 applications, and every pink line on this diagram is another copy of data going from one system. And when they first drew that little picture, they thought they had dozens of interface points, but they have thousands. And it's just a hairball. I mean, and every time you say, "Oh, I want to replace that box there," it's like open heart surgery. You can't just take it out and put another one in. All those little things are connected up, and the patient will bleed out on the operating room if you try and do that, which is why these things persist. Well, we want to talk about, there is another way. The real question is, because we all live with this, how bad is it? So we decided to ask some experts. Oh no, sorry, I got one more slide before the experts. And this is what you guys, many of you do all day long. We extract data, that's a copy. You make a copy of data, and then you transform it, that's another copy. And then you load it somewhere, like a data lake or a data warehouse or some other, and that's yet another copy. And you do that hundreds and thousands of times, just copy, copy, copy. So we ask a bunch of experts, how bad is that? It's not bad, it's bad, it's bad, it's not bad. Let's take a look at the not bad side. If you've got a data catalog, if you've got data sets, you got data all over the place, you don't even know how many things you have. If you're a data scientist, you pretty much have to make copies of all these data sets and make them conform to, your feature set or whatever it is you're doing. You're making copies. Maybe not so bad. And if you're into functional programming, every time you do anything, copy and write, copy and read, copy and write, copy and read, copy, 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 copy. It's not that bad, I can put up with some of this. But let's look at the bad side. It was actually Jans came across this. He had a client, and they had just done some analysis, and they sort of proudly said, we have patient data in 3,000 tables. As if that was good. Somehow they think that's good. No, that's ridiculous. If you have patient data in 3,000 tables, there's one thing I can guarantee: you're never, ever going to know what's going on with your patient. No human being can write a 3,000 table join, and no database management system can process a 3,000 table join. It's kind of ridiculous at some level. And yet, there it is. It's just sitting there. And people just say, yeah, well, we have this. And look at all the data we have. We're doing a project with an insurance company, and we're right in the middle of doing what we do, which is building them an enterprise ontology, a single, simple model of what all the information they manage. But in parallel, they brought in another firm that does data profiling. And they wanted to scan through all their databases, everything, just to find stuff. And they found that they had Social Security numbers in 8,300 places. They had acquired a bunch of companies, they had warehouses and staging, And of course, people care about Social Security numbers because it's PII, and it's one of our colleagues once called it toxic data. And this data isn't an asset. That data is a liability. It's like it's radioactive or something. You don't want that. And we're doing this model. And of course, in our model, there was exactly one place to put a Social Security number. And we said, we actually can't solve your PII problem. We can make it 8,300 times simpler, but you can't solve it. But 8,300, that's pretty good. And then if you've ever been in a publicly traded company that's gone through a Sarbanes-Oxley audit, it's hilarious. They get a war room and they fill the walls and they draw pictures and arrows and they spend 6 months and tens of millions of dollars to attempt to prove, I think they're just fooling themselves, attempt to prove that they know where those numbers on the financial statement came from. If you fill the war room long enough and draw enough pictures, you will convince yourself and the auditors and you hope for your CFO and the regulators that, yeah, we really know where that number came from. It goes through so many spreadsheets and other systems and stuff. You have no hope of actually knowing. So this is bad. So why, if it's bad, why do we keep doing it? And we do it because applications have to have it in a particular format for the application to understand it. And we're all addicted to applications, so there you go. So as long as you keep allowing your applications or your tools to define your data structure, you're going to keep copying. There's not an easy way out of that dilemma. I like this author, Roger Martin. He's written a couple of pretty interesting and provocative books. And in the middle one of them, I forgot which one it was, he says, you don't invent the future by just taking the present and changing it a little bit. You have to postulate something, and then you have to ask yourself, what would have to be true for us to achieve that goal? And so I'm going to postulate and then back up and say, what has to be true for us to get to the zero copy place? So we're somewhere in current state of copying like crazy. Our future state, I'm going to describe it here in a second, and there's just a series of things, interim steps that you have to go through to get there. We're going to postulate what these would have to be. So here's the end state. It would be pretty cool if you had all of your enterprise information easily accessible and the legacy lock-in gone and all the redundancies gone. That's a pretty cool end state, I think. We call this data-centric. when you get there, you would say, yeah, I'm data-centric. And if anybody read the blurb to come here, I did promise I'm going to distinguish data-centric from data-driven. It's coming up here in a slide or two. But that's where we're going. Oh yeah, here's so many companies think that they're data-centric because they're at least partially data-driven. But data-driven is how you make decisions. If you're not data-driven, you're making your decisions on your gut and heuristics and judgment. And if you are data-driven, you're making your decisions based on data, which is a good thing. But that actually doesn't have anything to do with being data-centric, because you could be data-driven and still have 1,000 silos, and every silo is how you make a different decision. That's not, data-centric is changing the relationship of your data to your applications. And where data is what we call it the first-class citizen, and every use case conforms to the data, not the other way around. So, what has to be true in order for us to get to nirvana here? I think there's 5 things that occurred to me. We need, and I'll have a slide for each of these, so I'll just hit them real quick now and then go in a little more detail. Application neutral, end user understandable, born integrated, read and write directly. So, slide for each of these. But the preamble, you can sit there and hypothesize, gee, what would have to be true? And then you go, oh, this is already true. You can do this tomorrow. It's not some hypothetical. I mean, we do this all the time. So, first off, as long as you allow an application designer, developer, vendor to dictate your data structure, data names, all that kind of stuff, you're just not going to get there. So as soon as you say, oh, I have to go somewhere else, that somewhere else is I have to have an application neutral way of defining my data. And it's actually a little harder than it sounds. We have a client, and they have a bunch of application systems, and they want to get the data out of the HR system and send it to the payroll system. And they have some goofy made-up name of something in one of their systems, and they wanted to put that in the core model. No, don't do that. You're going to perpetuate this completely arbitrary application thing, so don't do that. So, you can't have this be made up from an individual application. And what you want to have, it's an open standard called RDF. It's been around for more than 20 years. It is stable as can be. It just works, and it is application neutral. Once you've expressed your data in RDF, Resource Description Framework, you're well on the road here. This is Google's knowledge graph. It was originally based on RDF, but Google being Google, they made their own proprietary version of it. But they have all, the Google knowledge graph, all knowledge that Google has is stored in an application-independent format, just like this. And you can do the same thing. It's not really that hard. It takes a little thinking and getting used to. So everything, when you saw those nodes and edges in the previous thing, everything is in this one format. It's almost as if there's only one table in your entire enterprise. One table with 3 columns, really deep. Except, obviously, if you try to do that in relational, the performance would be horrible. People like Jans and Fleury and stuff who are here have figured out how to make that performant. But that's the first part of it. The second part is that everything, both the data and the metadata, are all in the exact same format. It's all just a triple. In this little example I borrowed from the web somewhere, we have cats. An individual cat is a member of the class of all cats. That's a triple. And cats are animals. That's a triple. And the fact that zoos host cats, and it's a little bit weird, but everything you could possibly say is in a triple, and it all can be intermingled such that you can introspect it. If you find some data, you can find what type it is, what it's related to. You don't have to have this pre-existing knowledge of the metadata before you even look at the database, because it's all there for you to discover it. The second thing is we've gotten used to the idea of, in fact, many of our livings depend on the idea that these data models are incredibly complex. And we need data stewards and data this is and data that's just to understand what's in there. Well, no, let's quit doing that. That's actually not a good idea. Turns out, and we've seen this in dozens and dozens of industries and clients now, so we know this with 100% certainty, every enterprise has a single, simple model at its core. It's hidden in all that complexity, but it's there. And this model, to get down to the level of fidelity you need to actually do all the reporting and analytics, all this other kind of stuff, you need somewhere between 400 and 1,000 concepts, which is not that much because most applications, individual applications have more than that, and you've got hundreds or thousands or tens of thousands of applications. So this is many, many, many orders of magnitude reduced. And what we've found is as you find new data sets and new databases and new all this kind of stuff, almost all of it, if you really stare at it hard and look at it, conforms. It's a proper subclass. We say that it conforms to the covering concept in the shared enterprise ontology. And what that means is if you can understand this core model, you can understand and find all of the information of the enterprise. Pretty big thing. And just to give you a further, we usually do these ontologies and that kind of people look cross-eyed when we do that. So I'm starting to think of simpler ways to present this. So I decided to go with Jeopardy. This is literally, I just took the top, I think it's 28 concepts that we find over and over and over again, and just said, if you understand these 28 things, you can find everything in your enterprise. And you already know most of them. These aren't even hard. Person, building, event, commitment, document, place. Most people know. Now, you have many types of persons. You have employees and patients and prospects and blah, 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 blah. But they're all people. And there's organizations, you've got your customers and regulators and all that kind of stuff. It's really not that complicated. It doesn't have to be that complicated. There's one more level of detail underneath this, and then you're at instances already. This idea, right now, as Peter sort of suggested, data is born in silos. That's where, it's some system integrator or data warehouse person's job to shepherd it along and get it with the rest of its kin, if you will. Those 3,000 patient tables, let's put them all together. When you finally get somewhere, when the data is created, you just create it in the graph, and it has an identifier. We run our company with a graph database, and my identifier and many of my triples have been the same for 14 years now. They just were born, they went in the graph, they're connected out, I have a lot more, I worked on this project for this client and all that kind of stuff, but really the core of it is just born with a permanent identifier, connected up to everything it needs, both its metadata and anything it's related to. One of the other things that distinguishes this, I think, from a lot of other approaches, when I said what needs to be true, you have to be able to read and write directly to your data store. And this is where data warehouse, in some ways people say, data warehouse, isn't that data-centric? Well, it is kind of. You rounded up a bunch of data and you put it in one place. But the data warehouse is dependent upon all those legacy systems. That's where it gets its data. So it's sort of in a deal to keep those legacy things in place, because as soon as you get rid of the legacy system, the warehouse isn't populated and it's game over. So what you really want is knowledge graph that has most of your data, but then you could update it in place And after a while, you say, if I can update this in place, I don't need those legacy systems. That's where the light bulb really goes on. This data warehouse here is perpetuating these things on the left. It's not getting rid of them. It's enabling them. And then one last thought here is the whole data warehouse and data lake and all that kind of stuff movement fundamentally says that co-location is the important thing. In fact, data lake is really saying co-location is more important than structure or meaning. Just put it all in one place and we'll work it out. Well, that doesn't really work all that well. And actually with this data-centric stuff, I got a lot of time. Co-location is nice. A lot of stuff you co-locate, you can query over more rapidly, but it's not essential. And in fact, you can literally change your mind. You can wake up one morning and say, I used to like to have all this transaction data co-located with my customer data, but nobody accesses that often. We'll just put it somewhere else, and we'll get to it when we need it. What is fascinating, this is what federation generally looks like. I just stole this on the web somewhere. Somebody asks a question, how many bags of dog food? And the federation layer interrogates 2 other systems to get an answer. Yeah, okay, that works. Doesn't scale very well, frankly, but that's what federation is. Here's where we want to go with this. We want to say, take all that stuff that was in there, just put it in the graph, so that when you write a query, it's with that simple language from the Jeopardy screen there. But then, if you really do have some very large big data, like clickstream analysis and IoT and all that stuff with billions of trillions of pieces of data, you probably don't want to put them in the graph. You want them somewhere else. But if you have a little catalog, if you have an adapter, when you write you don't even need to know where it is. You can write a query on the triple store, and it goes through the adapter into the IoT or the big data or whatever it is, brings it back. Not as performant as if it were in the graph, but the fact that it's doable and reachable and findable, pretty cool thing. So, these are 5 things that would need to exist. I always like this cartoon where the guy says, what we need is a brand new idea that's been thoroughly tested. But that's what this is. This has been tested for 15 years. It's rock solid. And yet, for almost everybody we talk to, this is a brand new idea. Never heard of this? Wow. What is this? So it is literally the brand new idea that's thoroughly tested. We've got an application neutral way to express data, so no longer dependent on those application software vendors. We've got a model that, in fact, one of our clients once said when they looked at the model, they said, this is something that a motivated analyst, that's the difference, he used the term motivate, this is something a motivated analyst could absorb over a weekend. I said, yeah, that's the point. Whereas that's not true for almost all of your other systems. Not only would it take you more than a weekend to understand the model, to actually use it and do the joins and all that kind of stuff is an amazing amount of work. We now have a situation where you don't have to birth your data in silos and hope that some system integrator gets it connected up with everything else. It can just be born where it belongs, in context, and live that way for the rest of its life. There are tools and architectures that allow you to both treat this like a data warehouse, a smart data warehouse. It's a data warehouse where everything is connected and interrelated. It's not just facts and dimensions. It's everything. But you can write use cases against it, write transactional systems. And we're gonna talk about that here in a second. And then the final thing is, yeah, you can co-locate a lot of your data. In fact, we would recommend of that Jeopardy board I had up there, most companies should probably have most of that, not all of your documents necessarily, depends on the size of your company, what kind of documents you have, not all of your big data, but you should be able to reach your documents and reach your big data from this shared model. So I'm going to do 3 case studies to talk about how this works in a small company, how it works in a mid-sized company, and how it works in a very big company. It works in all of them, but it kind of shows up a little bit differently. We're a small company. There's 30 of us. We built our own internal system that mostly managed time cards and project management, because we're consultants. That's what we do. We do time cards and project management, and we've been running that for 14 years now. That's right, because we're converting to the new version. Although the interesting thing is new version, but same triples. For instance, my identifier, somehow, I look at it every once in a while, I'm person 6. And you go, I founded the company. How come I'm person 6? And to know the answer to that, you have to talk to our intern who built the system 14 years ago. He decided who was person 6. I was person 6. But yeah. He's no longer with us. I'll probably delete him, but out of spite. And what we discovered at one point, which is kind of embarrassing, because we're champions of data-centric. I went and looked. We have 30, I think we have almost 30 systems to run our business, which is really embarrassing. We have QuickBooks and Rippling for payroll and Pipedrive for CRM and several homegrown systems for staff planning and all. It's embarrassing. So we said we're gonna deal with that. We're gonna be a poster child for how you run a program to get rid of all those. In fact, getting rid of QuickBooks and all accounting is my real jihad that I'm on now, because as you'll see in a minute, about 2 years ago, we decided, while this works for large companies and we love our large clients, it's very incremental. They're adopting this very glacially, which is okay. I mean, it pays the bills, but we really want somebody to get done. I want somebody to get to the end game so we can point at them and say, yeah, that's what we're talking about. And so we started thinking about this, and our methodology, our approach is kind of bespoke. It's professional services, and you have to design stuff and convert data and all that kind of stuff. So we said, in order to speed this thing up, we have to have a lot of the end thing already in place. And we said, in order to do that, we'd have to specialize in some vertical industries. And we decided, a good vertical industry would be professional services, partly because we understand that we can play on ourselves, but there's all kinds of engineering firms, architectural firms, consultants, lawyers. They're all more or less the same business model, and there's a lot of them that are kind of medium-sized that could get converted. So we said we have to build a model of professional services, build enough architecture to implement it, build systems that are model-driven. What that means is, it's this sort of no-code, low-code approach that Gartner's now trumpeting about. So anyway, we decided that's where we're going to go. But when we sat down and started designing it, the weirdest thing happened. I used to work for Arthur Andersen, the part that became Accenture, and in my early part of my career, I built a lot of accounting systems. So I know accounting pretty well. And then it suddenly occurred to me, I haven't touched an accounting system for 25 years. Because most of our clients, I think it's a solved problem, or they don't want us to touch their books or something like that. But as you return to something and put fresh eyes on it, I started looking at this and going, wow, if you think about accounting from a semantic standpoint, is really different than, ledgers and debits and credits and account numbers, all that kind of stuff. So, and actually Cheryl is here. Cheryl's a professor of accounting at Grand Valley University. We connected up and are writing a book now about accounting, data-centric accounting. What does it look like? And what it looks like, a sneak preview, is, right now, accounting is just like everything else I've been talking about today. Something happens somewhere in the business, and it goes into some system, and it bumps along for a while, and then it eventually gets to the accounting department, maybe as a piece of paper. Half the time it shows up, and somebody keys it in, and they scratch their head, oh, what account should I charge this to? And is this a revenue recognition thing? And all that stuff. And you just go, man, that doesn't have to be. The event occurs, and by the way, almost every event that changes the books and record of a firm occurs outside the accounting department. It occurs wherever it occurs, on a shop floor, or with salespeople, or procurement people, or whatever it is. Anyhow, imagine the event occurs, and your accounting policy is machine executable. It's just described in fact, it's described in the table, but it's a table in a graph. And then what immediately converts into a financial transaction, immediately being within seconds, and is immediately in your financial statements. I mean, you could just sit there and stare at your financial statement and watch the numbers change because somebody out there on the shop floor is doing something. And, I'm gonna make a little odometer just because I think executives find that amusing. Anyway, that's the impetus of that, and that's what we're doing. We hope this book is going to be done by the end of the year. So that's a small company. A medium-sized company, and this one just serendipitously is almost exactly what we were looking for, a professional services firm of a medium size. It's the Institute for Defense Analysis. They have 1,500 people, most of whom are essentially consultants. They consult for mostly the Department of Defense. And they have a model, just like the one I said. It's less than 400 classes for everything we've found there. Now, we don't have their clients' data. I mean, it's behind firewalls, and you have to have top secret clearance, and but everything other than their client data, everything to run their business, HR, accounting, project management, portfolio management, managing a library, it's all in there, 400 classes or so. It's all it takes to, and their initial implementation is they're taking all that data and putting it in the graph and using it as their integration hub. Because they still have an accounting system, an HR system, all that kind of stuff. But instead of point-to-point integration now, it's coming through the graph. And then the intent is, over the long term, just start building functionality, directly on the graph. And then finally, also works in very large companies. One of our colleagues, Dan Carey, is going to be speaking later this afternoon at 4:45 about this bank, which up to very recently, they were very secretive, how banks are, but now they told us we can use their name. It's Morgan Stanley. And what's interesting about them, and they have a very interesting zero-copy study, and there's, in the middle of this case study. But we started in the legal department. So the legal department of banks has a department called information management. And at first you might think it has something to do with IT or the CI. No, it's what the legal department thinks about information. And their scope is for the whole bank. They're supposed to do retention management and e-discovery and all that kind of stuff for the whole bank. So their remit is for the whole bank. So we went in there initially, and they had gotten in a lot of trouble. They had a court case, and it's public knowledge, where the judge fined them, I think it was $2 billion, And I found that by just looking it up. I'm sure they negotiated it down from there, but because of how they were not doing records retention very well. So they were motivated to do something about it. And our sponsor had this hunch that he couldn't really NLP read all the 20 billion documents they had and try and figure out, should we retain this or not? He said, if we just knew the context, if we knew the folder and who put it there and where they charged their time to, we could probably figure out what we should do with this for retention purpose. So the first project, we just took all their employee data, put it in a graph, all their chart of accounts and all that stuff, put it in the graph, all their cost centers, all about a dozen different sources, put it in this one integrated graph, a little bit of very lightweight NLP, and you could figure out pretty much what was in most of all these folders and databases and what you ought to do with it. What was interesting, and then it sort of started growing, and when we finally got to technical assets, banks are under a lot of pressure to have a database of, where are all your applications, where are your servers, what jurisdiction are they cross, is data traveling in and out of China, all that kind of stuff. You have to have a database, and they have 10,000 applications, so it's complicated. And so when they started, they decided to use graph for that problem as well. And when they started into it, the first thing they said is, we need some employee data. And they heard that over in records retention, we had the employee data in a graph. They said, why don't you give us a copy and we'll transform it for what we need? And we went, no, it's a graph. Those triples aren't going to change. The fact that employee 1234 has this email address and reports to this department and started on this date doesn't need to change. It's just an atomic fact. There's no reason. You might want to add some stuff that we don't know. You might want to ignore some stuff, but no reason to change it, no reason to transform it, no reason to even copy it. And so finally, they went, okay. Saved them a huge amount of time and eliminated that whole set of copies. So, and also, so that was the first bullet point down there. The other thing that I'm just starting to observe as I watch their evolution, and this is, I think, how most companies are going to evolve, at least most large companies. First, you have to do some sort of pilot. You have to get some people socialized and understand that this can really work. Then you have to start populating the graph and get a lot of your real data. People don't believe this until they've seen their own data in the graph. So you start doing all that. And then at some point, you get a little more architecture to where you can start building use cases. Because people, we can say this conceptually, but until you actually see it, it doesn't occur to you. You look at all your data there and you say, well, wait a minute. I could just update this right here. I don't have to wait for somebody to enter it into this other system and make its way through the weekly or nightly update. So right before that point, when that light bulb goes off, what we were observing at Morgan was they had been launching another application project just in legal and compliance and risk, just in that area, almost every year. And these were not small, these are $10 million projects. In come all the consultants, you do yet another one of these. Over the last several years, been almost no new legacy systems. So we call that phase legacy avoidance. So, that almost by itself is worth the journey. But then the next phase that they're into now, I call legacy erosion, where once you start building a use case and you update the graph directly, and you start going, wait a minute, so now I don't have to do, maybe I'm not ditching the whole legacy system, but what if I just quit doing some of these functions in the legacy system because the data's already here, I can do it here and save myself. And you start peeling away at the legacy system, you start eroding it. And then finally, and this is what is scheduled for next year, is legacy replacement. Now as they're starting to look at some of those systems, they're going, wait a minute, we have the data in the graph. There's just a little bit of functionality that the system does. Why don't we just take the functionality, re-implement it, and then whoosh, get rid of the legacy system? So I think, that's the progression. I think that's the real important end game. And for a large company, it's going to take a while. Small, that's why we want to be doing some stuff with smaller companies as well. So here's I got plenty of, oh, no, I don't have plenty of time. I thought I did. It's actually, this whole application-centric mindset is what causes most enterprise information dysfunction. It's just this way of thinking. The way out, you have to think differently, start with your data. It should be good for you guys, you're at a data conference. You need a little bit of new infrastructure, but it's not really that expensive or that unusual. And you need to do some kind of pilot. So, if you want to pursue this further, we have some copies of my book. I'd be happy to sign them. You have to buy them, of course. We have a booth here. The first one, Software Wasteland, is where I describe in pretty graphic detail with lots of examples just how bad it is. I think you have to hammer on that a lot because everybody's complacent. They think, oh, it's okay, it's not so bad. No, it's bad. It's really bad. And then this other one is kind of the way out, what to do instead. You might want to take a picture of these after I do the reveal here, and then I have a minute or two for questions. We have a manifesto. About 1,500 people have read it. It's really kind of inspirational because they say why they're signing it when they sign it. I get inspired every time I read them. A lot of people from all kinds of places. Some guy named Ruben Sayara or something, I forgot how to pronounce his name, built a course called the Data-Centric Executive Course. It's really pretty good. It's got a lot of nice sound bites. It's kind of at an executive level. We do monthly meetings. There's one, and you can find them on our website. There's one called the Estes Park Group, where people who are interested in the architecture that you have to have in place to make this work come together, and we invite a lot of other vendors, because there's lots of people that can have part of the puzzle. Right now you can't just buy the whole thing out of the box, so people are assembling it. And then our upper ontology, the starting point for our models, is called GIST. We have monthly meetings for that. Bob Seiner is here, but not in the room. I've been writing articles on his website for 8 years now. So every quarter. So there's 32 data-centric articles out there if you ever want to pursue this further. And of course, feel free to send me an email. If you want to take a picture of this, by all means. And I have a minute for questions. Yeah? And then you. Mm-hmm.
Once you have all the data integrated, so how do you protect the data? Proper user from the illegal user, from the override, from the cyberware,
Yeah. Yep.
So once you're on the web, how do you implement any privacy or security?
Yeah. Those are great questions. I don't know if everyone could hear it, but the question was very astute. Once you put this all together and it's all connected, they have this thing called follow your nose. Once you get on one node, you can just start following these links, and you can easily wander into stuff that you shouldn't see. I mean, that's a classic problem, and there's 2 or 3 solutions to that, but it has to be part of the architecture. One is partition some of your data, put it somewhere, and put a password around it. That's kind of the simple, crude way. The more sophisticated way is closer to attribute-based control, where you have to say, based on who you are, what can you get to. And if you want to come by the booth, we can go into that in a lot more detail.
I'm wondering if I can get out of this presentation understanding what is the really true definition of zero copy. I can extrapolate from this that it's probably this concept that an enterprise will have to create a database, a graph database to include all their data repository in there, and that will be enabling them definition that will not require to copy their data around.
Right. And I don't know if everybody could hear that. It was kind of what's the real definition of zero copy and yeah. Yeah.
Snowflake, they advertise, oh, we have zero copy something.
Yeah, do they? Okay. Yeah, in the final end game of this, you would have a knowledge graph with all your enterprise's information. You know, imagine this, and you take a new order from a customer. That taking the order is just a use case on the graph, and it goes into the graph, and there's no more need to copy it. It's just in there. So there's one copy. It's not zero, it's really one. But there is one copy of your data. Now, for all kinds of reasons, you will probably take data out of the graph and run it through some analytics. You wouldn't have to. You could run analytics directly on the graph, but habits die hard.
Enterprises use the graph also for their transactions.
Mm-hmm. Yeah, you can. Yeah, absolutely. Yes. Yeah. Question was, can you use it for transactions? Yes. Probably not the huge high volume trading in Wall Street. They probably won't put that on the graph, but yep.
Very often. So what would it look like when you have 1 million customers? Like how does this graph behave when you've got 1 million customers? Or you can have 1 million nodes.
Oh yeah. So you start, and to Jan's left, because he's worked with some healthcare companies that have hundreds of billions of triples in graphs. Now you end up having several graphs federated. Typically, somewhere around 1 billion or so, you have to start thinking about performance. But up to that point, you almost don't think about it much. Really, when you scale it up.
Because you first talked about the things, right?
Yeah.
It's very simple from that perspective.
Yeah.
But when you're looking, visually navigating or how are we going to navigate the data? We know how to navigate table structures, right? But you're trying to navigate your data and you're looking, searching, like how do you navigate millions of nodes?
Yeah, there's a query language, and you use either that or there's some visual languages as well. So I guess I've run over my time, but thank you. Thank you.